Let me reiterate for everybody to view. When we calculate average velocity from initial and final velocity, we're averaging the initial and final velocity, which involves adding them and dividing by 2. Does not involve any subtraction. You don't average two quantities by subtracting. So V bar is the average of initial and final velocities. Again, provided V versus T is linear. Means that V bar also is halfway between V naught and VF. That's something worth understanding, but let's focus on V bar as the average of initial and final velocities. You don't get the average of two quantities by subtracting them. Okay? You add the two quantities and divide by 2, as everybody knows. There's confusion here, though. What's the source of the confusion? The source of the confusion is that you have also this average rate of change definition of average velocity. And which one are you going to apply if you know VF and V naught? Well, you're not going to apply the average rate of change definition. If you try, it's not going to work. If you know how to apply it, and let's assume that you know how to apply it and that you practice that. So if you go back to the rate of change definition, you're not going to make the mistake of subtracting here and dividing by 2. But still, how do you get around this confusion? You get around it because you have to distinguish whether you're in a situation where you add the two quantities and divide by 2, that is whether you're averaging two velocities to get an average velocity, or whether you're applying the rate of change definition, which means you will have a change of position divided by a change of clock time. You won't have velocities. You'll have two positions, or a change in position. Okay? So, if you've got the two velocities, you're going to average them to get the average velocity. So you got to know whether you're averaging two quantities or applying the definition of average rate of change, and it's pretty important to keep thinking about which it is you're doing. Which is another reason it's so important to be able to think back to the definition of average rate of change and build that definition into a solution. Pretty soon it gets automatic. Pretty soon you learn how to distinguish. Pretty soon your intuition will distinguish. But you've got to take those steps in the early stages.